Now we're going to take another look at complex numbers, which are the numbers that have an imaginary component, where you're taking the square root of a negative number. But we're going to talk about another form of writing those and how to graph them. As a quick reminder of what complex numbers are the ones that have an I in them somewhere, and that I represents the square root of -1. So whenever you're taking the square root of a negative number, we usually pull the negative out and write an I somewhere in the problem instead. It's also commonly used at the same time. Many times you'll end up multiplying some i's together or squaring both sides of the equations. So it's also important to know that I squared ends up equaling -1, because the square root of -1 times the square root of -1 is -1. So these are two facts that will often be used when you're dealing with complex numbers. Now, the standard form of complex numbers that you've had the most experience with is in this form, a plus bi. There's the real part of the number that does not have an imaginary value, and then there's the imaginary part, which does have an I attached to it. So the A and the B represent both the real and the imaginary parts of the number. And this is what we call standard form of a complex number. And sometimes we just represent this whole complex number by using the variable z. Usually z is used for representing complex numbers. Well, in this lesson, we're actually going to be focusing on a new form of writing the complex or imaginary numbers. And this new form, it can also be called polar form. So whether they say polar or trig form, you would be referring to the same thing. This is going to come from the a value being equal to r times cosine of theta. If you distribute r through, that's what this ends up equaling. So the real part is r cosine, and if you multiply r times I sine of theta, then the b value, the imaginary coefficient, is r times sine of theta. And you can also see that written over here. So if you're asked to find a or b, it's just r cosine of theta and r sine of theta in the same way that we were dealing with the polar coordinates before. Some questions will ask you to find something called the modulus, or the absolute value of a complex number. Whenever they ask for either of these terms, or if they just mention something about that r number, that's actually the diagonal of the triangle that I have drawn here. So a represents the real part of the number, b represents the imaginary part of the number, and r is the diagonal, which is also called the absolute value because it defines the distance from the point to the origin. So they could ask you for this in several ways. They could say find r, or they could say find the absolute value of the complex number z, or they could write the absolute value of the complex number in standard form here, the a plus bi. No matter which way they ask for it, what you're going to need to do is take the square root of a squared plus b squared. This is basically just the Pythagorean theorem because we do have a right triangle here. So we're saying that a squared plus b squared equals c squared, and then we're taking the square root of both sides of the equation to find that r value. The negative value doesn't make sense. It doesn't make sense to have a negative length. So that's why we're not having to worry about the plus or minus value when we take the square root of both sides of that equation. So modulus or absolute value, either way, take the square root of your a and b values. Another concept that's important for this section is being able to actually plot the points given your complex numbers. So if you know what a and b are, then a, you can basically just think of this as the x value, and b, you can think of it as the y value. So whatever the real part of the complex number is, whether it's a positive or a negative, that's just going to be how far you move to the left or to the right. That's why this is labeled as the real axis here. So if you have a number that doesn't have an I, that's telling you how far to move left or right. The number that does have an I on it is the b value. That's the one that's going to go in the imaginary direction. So the imaginary axis has become your y-axis. So if it says something like 3i, that would mean that you go up 3 units. So whatever the b value is, positive go up, negative go down. And then you're just drawing a dot somewhere on the graph that will represent the complex number z. So a plus bi is a plus b. Here are a couple of real quick examples of graphing some complex numbers. Now this one does have both an a and a b value. So since the real number a is equal to positive 1, that means go right 1. And then the b value here, this imaginary number, is negative 3. So that means I'm going to go down 3. So just think of this as an x and a y. We're going to go right 1, down 3, and draw a dot. And that's it. That's the graph of the complex number. It's just this one coordinate, just like plotting the point 2, 3 or 5, 4. It's just a single dot on the graph. Now this one's a little bit trickier in the sense that we do have a b value, but there is no a value. Well, that just means a is 0. That means we do not have a real number being added or subtracted to the imaginary number. So that means we're not going to go to the left or to the right at all, but we are going to go up 2 units. So this dot would land right here. They could also do the same thing the other way around. If you don't see an I, you just have a number like 5, then that would mean go to the right 5, but don't go up or down. So A is your left to right motion, B is your up and down motion, draw the dot. That's it. So now let's look at an example of taking a complex number in the standard form and converting it to the trig form. So the trig form needs to know both the r and the theta values. This is very similar to what we were doing in the last unit where we needed to find those two numbers. And the formula for this, it's still going to come out pretty much the same. We have r is equal to the square root of a squared plus b squared. And then to find theta, we're still going to use tangent inverse of the y over the x, or the b over the a in this case. So to solve for r, I did the square root of the a value and the b value. Most important thing I wanted to point out here was do be careful about putting negative numbers inside of parentheses when you square them. Otherwise, your calculator will give you the wrong answer if you're typing this in. -7 times -7 is positive 49. So use your parentheses correctly when you're plugging in a negative number. And then 49 plus 9 is going to equal 58. And this square root can't be simplified, so we just leave it there unless they ask you for a decimal answer. So that is our r value. Now I will also point out that if you look back at that r value is the absolute value of the complex number we were given. So we've actually already found the answer to the second part of the question where it says find the absolute value of it. Well, that was this r value, the square root of a squared plus b squared. So this part is done. However, we still need to find the theta value. So I'm going to be doing tangent inverse. And for the polar coordinate section, we were calling it y divided by x. Well, we kind of have the same thing here. Think of the real part as your x value and the imaginary part as your y value. So now it's going to be b over a. Now, -7/3 is not a number you can do from the unit circle, so you do need to use your calculator on this. And I put my calculator into radian mode. It didn't really specify which format they want theta in, but usually we use radian for most things. They don't tell us. So typing this into the calculator in radian mode, I got -1.1659. Now remember, negative angles means that they are describing the clockwise rotation, but usually we like to describe our rotation going around in the opposite direction. So the coterminal angle for this would be adding 2 pi to it, which is 5.1173. But the other thing that you have to be careful about when you're doing tangent inverse is remember that there are actually 2 places on the unit circle that always have the same answer, and they're always pi away from each other. So I actually took this number, added 1 pi, that showed me the answer in the second quadrant, and then I added pi again to find the other answer back in the fourth quadrant. Now in this case, you can see that I've drawn this graph up here to show where the location of 3 minus 7i would be, so that I recognize that I should be picking the angle that's in the fourth quadrant. So out of these two theta values, remember this number is the same as this number, it's just coterminal with it, we are going to want to use the 5.1173 value. This value would be what we would pair with a negative r value, but we're not dealing with the negative r's on this. That was more for the polar coordinate graphing. So I don't need this number. I'm only going to need the positive 5.1173. Basically, when you do your tangent inverse, make sure you consider both values so that you make sure you're picking the right one. You need to pick the one that is in the quadrant that matches where your complex number is, your standard form of the complex number. So fourth quadrant, this would be a fourth quadrant angle because this is close to 2 pi, which would be approximately 6.28. So now we have both r and we have theta, which means we can write our trig form of the complex number. So the trig form is r times cosine of theta plus I sine of theta. Now that we know r and theta, we're just plugging those numbers into those respective spots, being careful to make sure that you pick the right theta value. And remember, we already said that when they asked us to find the absolute value, that actually was this number. So if that's a separate entry for a test question or a homework assignment, then you're just specifying that r value that we found here, the square root of 58. Okay, now let's do one of those conversions backwards. So now we have the complex number in trig form. So we have r cosine theta plus I sine of theta, and they're going to have us change it to the a plus bi form. So again, the important formulas to note here, just like with polar coordinates, instead of saying x equals r cosine of theta, we're saying a equals r cosine of theta. And instead of saying y equals r sine of theta, we're saying b equals r sine of theta. So the formulas aren't changing. We're just kind of adjusting what we think of as the x and the y value. Now we're technically considering y as an imaginary number going up instead. So here's our setup for what we need to evaluate. A is r cosine of theta, and b is r sine of theta. And I'm picking out r and theta from the information given in the trig form of the problem. And these are values that you can't do from the unit circle. We did technically cover them with some of the half angle and sum and difference properties, but I wouldn't ask you to use that on here. You'll just be allowed to use your calculator and then plug in what is square root of 5 times cosine of pi over 12 and what is square root of 5 times sine of pi over 12. Make sure you're in radian mode though. This problem didn't specify how many decimals to round to, so I just picked 4. But in general, the questions on the assignments will tell you whether they want you to round to 2, 3, or 4. It'll probably change from problem to problem. So for 4 decimal places, I got 2.1599 for the A value and 1.2941 for the B value. And then we're just rewriting this as A plus BI. So just don't forget to attach that I variable to the number you got for B. That's the number that I was saying earlier is equal to the square root of -1. So this is our imaginary part of the complex number. This is the real part of the complex number. And then usually Z is the variable we use for writing a complex number. So that's it for the notes. Hopefully you guys will be able to do both the plotting of points and converting between the two coordinates. Again, everything essentially just comes down to the same formulas from the last unit, where X is being replaced with A and Y is being replaced with B's instead.